Thanks to Masterworks for sponsoring today's video. The moon is our closest celestial neighbor. It's the brightest object in the night sky, an unusually large natural satellite for a planet of our size, and so close that its gravitational pull slightly lengthens our day. Thanks to this proximity, we've been able to observe, photograph, and even visit it. We know more about the moon today than we do about any other celestial body in the solar system apart from Earth. And yet, there are things about it that remain a complete mystery. Thanks to high-definition photographs captured by the Lunar Reconnaissance Orbiter, some of these mysteries are finally coming to light. What can we learn from these incredible images? And what amazing discoveries lie just around the corner? I'm Alex McColgan and you're watching Astrum. Join with me today and you will see some of the most recent, spectacular and puzzling images of the moon, captured in breathtaking detail by the Lunar Reconnaissance Orbiter. The LRO has been scanning the moon's surface since 2009. It's equipped with a powerful camera capable of taking high-definition photos, which it sends to NASA's Data Planetary System. The LRO can send up to 155 gigabytes of data per day, or 55 terabytes per year. By comparison, New Horizons took a full 2 years to transmit the data from its one Pluto flyby. Although the LRO was launched over a decade ago, it's still operational, and we are constantly learning new things about the lunar surface thanks to its high-powered camera and topographic mapping capabilities. Let's take a look at one of these images. At first glance, it may seem unremarkable, but a deeper look tells a different story. See those two large, round depressions? Those are impact craters, much like countless others that blanket the lunar surface. But if we zoom out, we see that these craters are located on an unusual dome-like structure. This is Mons Gruithuisen Gamma. Look how the western side of the dome appears lighter where the sun's light is reflecting off its steep slope. By contrast, the western sides of the craters are plunged into shadow due to their low elevation. Shadows on the moon are so dark compared to Earth due to the absence of Rayleigh scattering in the atmosphere. The moon has no atmosphere, so the only light that reaches shadowy regions are reflections from the lunar surface itself, which isn't actually that reflective. It is generally very dark, with an average albedo of 0.12, about as dark as wet soil. Directly to the dome's east is a dark shadow cast by the dome itself, and it gives you a sense of how tall it is. The dome is towering, with a slope of up to 20 degrees and rising 1,500 meters above the lunar surface. With a diameter of 20 kilometers, it's equivalent to the metro area of a mid-sized city. That's pretty massive. Zooming out further, we see that the dome is surrounded by darker and much flatter terrain. This plain, or mare, is the result of basaltic lava flows that flooded the topographic lows around 4 billion years ago, resulting in the even surface you see now. Think of it like ice cream dripping into the crevices of a wafer cone. Zooming out further still, we see a second dome located to the southeast of Mons Gruithuisen Gamma. This is Mons Gruithuisen Delta, and it's even bigger than its cousin, towering 1,800 meters above the surrounding surface and spanning 27 kilometers in diameter. The dark basalt plain that surrounds both domes is part of a vast mare known as Oceanus Procellarum, or Ocean of Storms, which covers a full 10.5% of the lunar surface. I don't know about you, but I think ocean is a fitting word. The domes look a bit like islands. It is believed that the Gruithuisen domes, like the Oceanus Procellarum, were formed by ancient lava flows. But why did they leave these unusual structures? Believe it or not, there may be clues here on Earth. This is Mount St. Helens, an active stratovolcano located in America's Pacific Northwest. Maybe you can see where I'm going with this. As you can see, it's shaped a bit like a dome. Stratovolcanoes like this one are the result of pyroclastic flows of silica-rich materials like rhyolite, dacite, and andesite. Once expelled from the Earth's crust, these high-viscosity lavas move slowly as they cool, hardening into dome-like or conical formations over time. We suspect that the Gruithuisen domes, like terrestrial stratovolcanoes, are made of highly silicic material, and recent thermal measurements by the LRO's Diviner instrument support this theory, suggesting the domes are compositionally different from their surrounding plane. So, unlike the moon's basalt lavas, which settled into smooth, low-lying surfaces, these more viscous, silica-rich lavas extruded slowly, like thick molasses, eventually cooling and leaving the massive domes you see now. But here's where it gets strange. On Earth, stratovolcanoes like Mount St. Helens are a unique product of water and plate tectonics. At the convergence of two tectonic plates, a subduction zone can occur where colder and denser material from an oceanic plate is thrust under the less dense plate and back into the Earth's blazing hot mantle. The remelted material results in silica-rich magmas like rhyolite and dacite, which then rise. But unlike here on Earth, neither liquid water nor plate tectonics are present on the moon. So how did these silica-rich magmas form? We're not sure. One explanation suggests that when lunar magma had nearly cooled and crystallized, it left a residual liquid that could have been extremely rich in silica. The problem, however, is that this process, known as fractional crystallization, would produce only small quantities of silicic material, which wouldn't be nearly enough to explain a massive 27-kilometer Goliath like Mons Gruithuisen Delta. A second model suggests that silicic material formed when basalt magma rose upward, causing rocks on the lunar surface to partially melt and form rhyolites and dacites. If this were indeed the case, then the Gruithuisen domes should be nearly the same age as the surrounding basalt plain. We don't know if this is true yet, but future research could shed light on both the chronology and composition of these mysterious structures. To me, the most exciting part is that we may be just a few years away from getting an answer. NASA plans to send a commercial Lunar Payload Services rover to this region in 2025. This mission will explore the moon's surface and collect rock samples that should shed light, not just on the mysterious Gruithuisen domes, but on lunar volcanism in general. And high-definition images taken by the LRO, like the ones we've been studying today, will provide NASA with crucial information for selecting a safe and navigable landing spot. It's exciting to imagine how this mission will add to our current understanding of the moon with on-the-ground imaging and rock samples, and honestly, I can't wait. Which of the two theories to explain the formation of the Gruithuisen domes do you think sounds more plausible? I'd love to hear your ideas in the comments. So there we have it. Almost everything you could want to know about the moon's Gruithuisen domes and the unsolved mystery of how these massive, eerily Earth-like structures came to exist. I hope I earned your like and subscription today. The moon may look boring at a glance, but to me it's like art. Speaking of which, did you know that the Apollo 12 lander had an Andy Warhol drawing smuggled aboard? If you are a fan of art yourself, then this sponsor may be of interest to you. Masterworks allows you to buy shares in famous paintings as an investment opportunity. This is pretty cool, as this had ever only been an opportunity for the mega rich. Have we been missing out? Yes. Contemporary art prices outpaced the S&P 500 total return by 174% from 1995 to 2020. Setting up an account is done in a few clicks, and you can already start browsing artwork for a painting that interests you. They even have a secondary market on the platform, so you aren't reliant on the painting actually selling before you get your money back. You can instead sell your shares there too. Now, usually there's a waitlist for Masterworks, but if you check out my link in the description, you can skip it entirely. If you're looking to diversify your portfolio, this could be a great opportunity for you that's definitely worth considering. Thanks for watching. If you want more of the moon, check out the playlist here. And if you found value in these videos, please consider supporting me as a member or on Patreon, with an added bonus of having your name added to the end of my videos. All the best, and see you next time.